Hello everyone, so we meet again in week 5 lecture. We will continue with the next subtopic or subchapter, which is differentiation on transcendental function. For example, we have trigonometric function, logarithmic, and another one that you are going to learn is hyperbolic function. Okay, so let's do some recap. So in this subtopic, we will start with differentiation of trigonometric function. So in this subtopic, we will see the derivation or derivative of trigonometric functions such as sine x, okay, cos x, tangent x, secant x, cosecant x, and cotangent x. Bear in mind that all the units for the trigonometric functions is defined in radians, in unit radians, and that we know that the sine x and cos x are defined and continuous everywhere. Alright, let me delete it so that you can have a better view on the notes here. Okay, now we do have the tangent x, secant x, cosecant x, and cotangent x. All these four are actually derived from, for example, tangent x is sine x over cos x, secant x is 1 over cos x, cosecant x is 1 over sine x. Meanwhile, cotangent x is the other way around, invert to the tangent x, which is cos x over sine x. And they are all continuous on their domains, okay, where the values of x, the denominator must be non-zero. And before we can calculate the derivatives of this function, okay, we already actually calculate the two important limits. This is the squeeze theorem, again squeeze theorem. So the squeeze theorem is actually limit sine x over x as x approach to 0 equals to 1, and the other one is limit for function 1 minus cos x over x as x approach to 0 is equals to 0. Okay, now we start with the derivatives of trigonometric functions. So I have received a few text WhatsApp messages from students, okay, section 1 and section 2, asking whether it is important to know the basic principle. For example, in differentiation, we have first principle rule. Okay, so I meant it to ask you to change your mindset once you entered into the university level, where you need to comprehend and have a very strong fundamental concept, okay, because in the tertiary education level, we don't want to only know how to apply and only memorize the formula, but there are some parts of it that you need to understand where does the formula comes from, okay, the origin of it, okay. So you need to you need to bear in mind that we don't want to only produce graduates that can only apply the techniques or the formula, but also have a strong, very valid in their knowledge in terms of the fundamental or the origin of something, okay, fundamental of theories. Okay, now let's go back to this, okay. Well, you know that if you differentiate, if you can recall your previous learning lesson from your previous institution, okay, from previous schools, that when you differentiate sine x, you will get cos x, okay. we know that this one, okay? So for example, if I can write this, so if you have y sine x, you know that dy over dx or y prime is equals to cos x, okay? But how come how come differentiate sine x you will get cos x? Okay, how can we derive this? Where does this come from? Okay, so we need to go back to the fundamental of it, which is by using the limit theorem. Okay, so this is actually what you did from the first principle rule. Okay, so that is why you need to learn it. And of course, like I said, first principle rule is a favorite question in test, so you need to get ready for that. Okay, by learning it, by understanding it. Okay, now we go back to this. I think I can skip this process because I bet that you already learned it. Okay, so we have sine x plus h minus sine x over h. Okay, this is the third step of from the first principle rule. And then you need to use the trigonometry identity. Okay, so if you got the module, okay, if you already received the module, or later on if you got the module, you can go to the last page. Okay, the last page of maybe I can go to the bookmark. Yeah, this one. So if you go to the last page, page 141, the trigonometry identity that you need to do or apply is listed here. Okay, so in our question just now, we have sine x plus h. So sine x plus h, you have to apply this formula, sine x plus y, which is sine x cos y plus sine x sine y cos x. So this is where we need to apply this in our let me scroll first, differentiation on trigonometric functions. So this is where this part come from. Okay, this one. So it is actually from the trigonometry identity up to this. Yeah, okay, and then we can factorize sine x. Okay, so from here you can apply the squeeze theorem. Yeah, so if you apply squeeze theorem, yep, on this part you'll get this one, you'll get 0. Okay, and this part you will get 1, so that is why you will get cos x. Okay, so this is how we can obtain cos x as the answer for differentiation by differentiating the sine x. Okay, now that is by using the first principle rule. So if we go to this one, so this one also show how to obtain the cos x, derivative of cos x. So we have y equals to cos x, the dy over dx is equals to negative sine x. So where does this come from? So you can refer to this example. I will not repeat it, okay, or teach you, because it is use the same concept. We use the first principle rule. Okay, and you need to apply the trigonometry identity to solve this. Okay, similar to the previous example that I shared just now. Okay, now let's continue with this one. Find the derivative. Okay, example 2.7. Find the derivative of this function, which is y equals to 5x sine x. So the solution for this is very easy. Okay, we have two different functions. Okay, we have two different functions, which is 5x and sine x. It means that okay, the question asks you to find the derivative or the y prime or dy dx. Okay, So in order to do this, you know that this is consists of two functions, which is 5x and sine x. Okay, you need to apply product rule. Okay, this is the first technique, which is product rule. And then within this technique, okay, you need to know that we have the trigonometric functions. So for that case, you need to differentiate it according to the values that we discussed just now, which is when you differentiate sine x, you will get cos x. Okay, so again, if you assume u as the 5x, okay, and v as the sine x, so if you differentiate u, you will get 5. If you differentiate v prime, you will get cos x. So the y prime is u v prime plus v u prime. So don't mix up the formula. So u and v prime is 5x, okay, cos x, right, like this. Yeah, if I can change the color. So u v prime plus v u prime. Okay, so yeah. So 5x cos x. The third one, the second term is v u prime, which is plus sine x times 5. Okay, so if you want to simplify it, you can factorize it. The 5 here is a constant, so x cos x plus sine x. Okay, I just noticed that some of you are not very good in trigonometry function. Okay, for example, yeah, we have here sine x dot times 5 here. You cannot simply put it sine 5x. This is wrong. Okay, because here the 5 is the constant. It should be in front of the trigonometry function here, the sine function. So 5 sine x is the correct one. Okay, you cannot simply times up it. Or for example, sine x plus x, you cannot simply put it sine x plus x. Okay, not this type of the mistakes or understanding that I encountered. Usually like this. For example, sine x plus x squared. So you cannot simply put it, you cannot simply dissociate it to become sine x plus sine x squared. Okay, so this is wrong. Okay, this is wrong. Okay, the variable in the bracket, it will stay together. You cannot just dissociate it like that. Okay, the trigonometry functions doesn't work like that. Okay, if you don't understand what I'm talking about, I guess it's time for you to review your algebra notes. Okay, your pre-calculus notes. Okay, about trigonometry functions. Now we go to example 2.8. I think we have done this example by using the first principle rule. I can't remember this one. Oh no, this one is sine. Okay, sorry, my mistake. Okay, you can ignore what I just said just now. Now we go to example 2.8. Okay, differentiate y equals to sine square root to x minus 5 with respect to x. Okay, so here what you need to do is that there is a function within a function. This is a composite function. Okay, so you need to apply the chain rule. Okay, you need to apply the chain rule. Basically, the techniques that you learn in week 4 will help you to solve the trigonometric functions, hyperbolic, or what is another one? Logarithmic functions. Okay, the techniques that you learn in week 4 will help you. Okay, will assist you in order for you to answer the differentiation on these functions, trigonal, hyperbolic, and logarithmic. So make sure you grasp the very well the understanding on the techniques first. Yeah, we have altogether 5 techniques. product rule, quotient rule, chain rule, and we have implicit as well as differentiation rule. Okay, now we go back to this. Okay, this is, you need to apply chain rule because this is a composite function, one of the composite function. Okay, so you need to pick appropriately the u. Okay, so the u variable here is the 2x minus 5. Okay, the v here, or the okay, this one is, we've got okay, the solution showing here. Okay, it shows you step by step. Okay, you can actually do pretty much quicker than this, but I will show you according to the module first. So, and then we have u, okay, square root, and then we will have y. Okay, y is actually sine v. So when you want to do the chain rule, it is dy over dx, because we want to differentiate it with respect to x. Okay, what you can do is that du over dx, which is u prime, times dv over du, which is v prime, and then we have y prime here, times dy over dv. So basically we want to get dy over dx, so that is why you need to write down the formula like this. Okay, so you can cancel out this. Okay, the basic idea is that, okay, to get dy over dx from the three derivative function, you actually want to cancel out this one, want to cancel out this one, and what's left is dy over dx. Got the idea? Yeah. Okay, let's proceed. So we have u prime, or du over dx. Okay, u prime is du over dx, is actually 2, right? Only 2. V prime is, you need to do something. This is half u squared. I just skip this one. Okay, straight away doing the differentiation for the power rule here is very easy. Okay, and then finally sine v, when you differentiate it, you will get cos v. So you plug in here, du over dx is 2 times dv over du is 1 over 2u, okay, half, power of half, and then times cos v. Now it's time to plug in the real value of u and the real value of v in terms of x. Okay, so 2 cos v is, what is v? V is u. What is u? U is 2x minus 5. So 2x minus 5 power of half. Alright. Divide by. Okay. So actually 2 and 2 can be cancelled out. Okay. So I just erase that one because it's already cancelled out. And what's left is cos v. We already changed it here, and the remaining is over u. U is 2x minus 5 power of half. Now this is your answer, final answer. I hope that there will be no one that will cancel out this one. Cannot, because why? Right? Because the first the variable here, 2x minus 5 power of half here, okay, is actually, right, is actually let me check. Yeah, this is actually corresponding or belong to cos. Okay, so it's a x function of to the cos, so you cannot simply cancel out like that. Yeah. Alright, I hope that one is clear to you. Okay, So the original answer is only this one, yeah. Okay, let me write it down again for you. So 2x minus 5, 2x minus 5. Okay, now let's turn to exercise 2.3. You can try to do it at home. Alright guys, so before I proceed with the next subtopic, which is hyperbolic functions, differentiation on hyperbolic function, about exercise 2.3 here. So this is the answer. Okay, so it is actually pretty straightforward, yeah. You can try to do this and try to get the same answer like me.